Hello one and all. So in this series of videos I am going to attempt to cover what I deem to be quote-unquote remedial material in the chem class that I teach. So all this means is that you've seen it before, whether it was another school or another class, typically physical science in the pattern of courses that we do here. So if you forgot this material, which no one would blame you, I'm sure it's been a year or so since you've seen these things, but I wanted to make sure that you had some kind of way to go back and review these topics. If they're completely new to you, then this should kind of provide that basic knowledge that you need in order to be successful in subsequent science classes. So the first thing that you kind of need to know how to do in really any of the science classes, chemistry, physics, are conversions. And at their simplest, this is just a converting from one thing to another. You can see the examples I have here are all imperial units. Imperial just means American, for lack of a better word. So these are things like seconds to minutes, days, months, inches, miles, feet. Nothing metric, nothing with prefixes. And so all we're going to do is to convert, in this first example, we'll go from seconds to minutes. I'm going to show you a slightly more complicated, or not complicated, but a long way to do these, because I know seconds to minutes, you can do that in your head, more than likely. You divide by 60, that gets you your thing in minutes. But just to show you a process, so that when you get to some of these longer conversions that might require more than one step, it gives you a roadmap to follow. So the first thing that I always tell the kiddos to do is to write down whatever conversion is going to get you from point A to point B. In this case, I see that my conversion factor, this equal statement here, it's called a conversion factor, has both my starting unit and my ending unit in it. So I know that this is just a one-step problem. But then the next question becomes, okay, great. Do I multiply? Do I divide? How do I get from, let's say, 15 seconds, but I want that to be in minutes for some reason? Well, we always take the thing that was given to you in the problem and we put it on the far left-hand side. Some teachers will have you do fractions where you have one number over the other followed by the multiplication sign. I like boxes because I find that whenever you start doing the multiplication side, occasionally things get honker-jawed and you can't tell what's being multiplied, what's being divided, how that works. Your first thing is always over 1. So if you are doing this, the fraction method, you would have 15 over 1. I like doing the smiley face because that is just a reminder that nothing else goes there, no other number. Now, in order to convert, I need to get rid of this seconds here because I want to go to minutes. The way that we can cancel something is by having it on both the top and the bottom. If you think back to your math class, if you were to reduce this fraction, top and bottom has a 2 in it, and then this allows us to cancel. If you're multiplying fractions, again, if it's on top and bottom, we can cancel it. So we're going to do the same thing here. I'm going to take this statement and turn it into one of these fractions. But who goes on top? What goes on bottom? I want seconds to cancel. I've already got them on the top. That means the next time seconds appear, it needs to be down here on the bottom. The number that goes with my seconds comes from my conversion factor. So I'm going to mark this out just to remind myself that I have used that piece. The other half goes on top. Seconds cancel, and I'm left with the unit that I was looking for. So this tells me if I multiply all the way across the top, 15 times 1 is 15, divided by, multiply all the way across the bottom, 1 times 60. I'm not doing that in my head, I apologize, too early in the year. That gives me 0.25 minutes for my answer. And that should make sense. 15 seconds is about a quarter of a minute, so double check your answers. Always temper them with a little bit of logic. So if we look at this second problem here, that's slightly more complicated. Again, I'm sure you can do it in your head, but for now I'm going to write it out in the full complicated method. Since I'm going from seconds to days, I don't know off the top of my head how many seconds are in a day. What I do know is that I do know that there are 60 seconds in 1 minute. So I've got seconds, but I'm not going to minutes, I want to go to days. Means I need another conversion factor. Well, let me think. What's bigger than a minute? Ooh, an hour. I got it. So there are 60 minutes in 1 hour. Okay, so now I could get to hours. Nope, I still want days. Well, phooey. Ooh, I know how many hours are in a day. So now, there's my starting unit. There's my ending unit. I'm good to set up my boxes. Once again, the number given to you always goes in that far left-hand box, over on this far side. You put a 1 underneath or a smiley face, whatever reminds you that no other number goes there. I want seconds to cancel, means they must next appear on the bottom. How many seconds? There it is. Takes care of that piece. You must use 1 complete conversion factor before you can move on. I should also point out that this is true. 1 minute has 60 seconds, so always make sure that your top and bottom agree. That takes care of the seconds. Now I need minutes. How many? There it is. The 1 hour goes on top. Let's see. Hours on bottom. It says 24 here. 1 day. And look at that. Everything cancels except that unit that I was looking for. Fantastic. So now we're going to multiply all the way across the top. So 20 times 1 times 1 times 1 is 20. Divided by 1 times 60 times 60 times 24. So it's 20 divided by that. Now, this gave me a really small number. Your calculator may have spit out this, which is just fine. However, my calculator spit out this. Recognize that these are the same number. One is in scientific notation and one is not. This E just means times 10 to the. So this is 2.31 times 10 to the -4th. If we look at this answer here, my decimal is placed 1, 2, 3, 4 places from that 2 and 3 position where it's located here. Since we have moved the decimal in front with all these zeros, that's why it's a -4. So either of these answers is correct. The last thing I should mention about these imperial conversions is the fact that you need to make sure that every answer has both a number and a thing. Because 2.3 will 2.3 what? Kumquats, pink elephants, butterflies. I don't know. So make sure you have a number and a unit. Alright, before I run out of time in this video, I do want to quickly mention metric units. Metric units are anything base 10. So this is the unit you will more often use in a physics class or a chemistry class. Our base units, if you will, kind of the starting place unit, are things like grams, liters, meters. These are the ones that I most commonly use in my chem and physics classes. And onto any of these base units, I can tack a prefix. And these prefixes are all factors of 10. That's what makes metric so nice and simple in order to convert. And I know that there are a bunch of prefixes. I'm just going to show you the ones that are most typically used in my classroom. I know there are more. If you would like me to go through them, please let me know, and I will happily do so. So, this list here goes from biggest to smallest. So, we start off with the kilo. We can do a kilometer, a kilogram, a kiloliter, if we prefer. So that is a prefix of a K in front of whatever I'm trying to do. And that means the prefix kilo literally means 1,000. So here's the number written out and in scientific notation. So 1 kilometer equals 1,000 meters. That's literally what this prefix means. If we were to write that out in words, it literally means 1,000 meters. When we get below this line, now we're starting to talk decimals, and this is a little bit more complicated because all of these prefixes refer to a piece of a meter, or a piece. I don't know where I wrote a B. So, for example, a centimeter. Centi is represented with the prefix of a C. 1 centimeter equals 1/100th of a meter. But that can be annoying when we start writing those those equal statements like we did with the imperial units. So a lot of times you'll see this inverted. Just like a penny is 1/100th of a dollar, but that's annoying to say. It's easier to deal with 100 pennies equals $1. So we can do the same thing here. We can say that 100 centimeters equals 1 meter. And we can do that for each of these prefixes as we go on down. Milli is our next smallest prefix with an M. So 1 millimeter is quite literally 1/1000th of a meter. But again, that's lots of decimals, negative exponents, gets icky to deal with. So it's much simpler to say that 1,000 millimeters equals 1 meter. On down, we have micro. Micro uses this funky looking U. So 1 micrometer is 1/1,000,000th of a meter. It is a tiny, tiny piece of a meter. Or we can say that there are 1,000,000 micrometers in 1 meter. I'm running out of time. Nano is the last one. 10 to the 9th of a meter, little bitty piece. So this, generally speaking, is the conversion chart that I use in my class because it eliminates those nasty negative exponents. Makes everybody's life easier. So let's see what this looks like in terms of a couple of problems. Let's see if I can do this in 2 minutes. Meters to centimeters. Actually, let's go ahead and do a two-step one. If you can do this in your head, congratulations. I always mess up the decimals, so I like to write them down. If ever you're going from prefix to prefix, it is best to always go through that base unit. So in this case, our base unit is kilometers, so our meters, so I'm going to go from kilometers to meters, then on to micrometers. So there's my little map. I know from my chart up here that there are 1,000 meters in 1 kilometer. Now I need to go from meters to micrometers. You can use either of these equal statements. If you don't mind the negative exponents, use it. I don't like them. That's just me. I prefer to think of things in positive exponents, which means that instead of talking about 1 micrometer, I'm talking about 1 meter, having 10 to the 6th micrometers. Let's see. Starting unit, check. There it is. Ending unit, check. There it is. Let's set up our boxes. 1.5 kilometers. Smiley face. Thing they gave me goes far left. I want kilometers to cancel, so they must appear on the bottom. How many kilometers, you asked? 1 kilometer, in fact. 1,000 meters goes on top. I'm in meters. Don't want those. I want micrometers. So meters must disappear. How many meters? 1. Puts 10 to the 6th micro on top. Meters cancel. Hey, look at there. I'm left with the unit that I was after. So we multiply all the way across the top. 1.5 times 1,000 times 10 to the 6th gives me a lot of zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Phew! Now that should make sense because a micrometer is a smaller piece than a kilometer. This is a big unit. This is a little bitty unit. Just like $20 in pennies, it's a lot more pennies than it is in dollar bills. That's icky. Let's put that in scientific notation real quick. Since it's a big number, the decimal is way back here, and we're going to bounce it until there's one number in front. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1.5 e to the 9th micrometers. I am about out of time in this video, so I apologize for going through that quickly. But if any of this is unclear, I have a secondary video in my playlists as well. Please feel free to look at that. Or leave me questions in the comments below, and I will go through this at a more leisurely pace if that would be beneficial. Let me know what helps you best. Otherwise, take care. I'll see you next video.